do this.
Ooh.
Hi. Hi.
Do you see just one slide, right, guys?
Yes.
Okay.
Yeah.
Tell us about yourself first.
Yeah, about myself. So I was born in Ukraine. I lived in 4 countries originally. In Moscow, after that in Israel, moved to US 20 years ago. Spent about 8 years working for MIT, Lincoln Labs, which is a lab funded by Department of Defense, CIA, FBI, such agencies, and I worked there as a researcher for cybersecurity. At some point, I left and I started working on AltaStata because that was my idea that came up, and that's a good thing to work at MIT because you know what's gonna be in industry like 5 years before it
Yeah,
happens.
right.
And I started working on encryption solution to secure AI and machine learning, hoping that will bust, and that happened now. So at this moment, I already have patent and working solution. We're doing pilots. We're working with some big companies, smaller companies. Google accepted us to their startup initiative and provided us credits. So we're happy to work with all the clouds.
Fabulous.
Google is, I think it's a leader in AI, so it's exciting to work with them. Yeah, and because we're a small group, so you can ask questions in the middle of my presentation. So let's start it.
That's great. Thank you.
Yeah, so I just want to, first of all, I want to talk about what is AI and ML ecosystem. So there are 2 main AI processes: model training and data processing in production. And for this, companies use data platforms. Data platforms enable to provide automation of pipelines, model training, testing, verification, deployment, and can do it in massive scale data processing. So they don't need to care about it. Platform can provide this.
May I ask you something? So I don't see, I see Amazon, but I don't see Google. Doesn't Google maintain a data platform?
Yeah, actually Google also has it, yeah.
What do you know what it's called?
In general, they have Gemini API.
Is that the same thing as something like Databricks or Red Hat OpenShift AI?
No, it's not something like Databricks. So yeah, I put just here different types of platform. Databricks is more for machine learning, for running machine learning on scale. Red Hat OpenShift is a containerized platform. It enables to create containers, and OpenShift AI enabled to create containers for AI. Amazon SageMaker is just, it's similar to Databricks. It uses
Okay.
Spark underneath.
Right. I'm just trying to figure out in terms of, this little ecosystem that you're laying out here, something that's familiar to me, that's all. But no,
Both,
I sorry to interrupt.
both Databricks and Red Hat OpenShift can work on Google Cloud.
Okay.
Okay, so, and for infrastructure, they need a lot of power, a lot of energy, hardware accelerator, NVIDIA, and other GPU cards. And what's specific for Google, they have, besides of GPU that usually they buy from NVIDIA, they also have TPU. That's their own technology, and that's ASIC-based technology. So it's very specific for particular AI tasks. Everyone uses vector databases for RAG, and companies use foundation models, for example, GPT, Claude, Gemini. And what is model? Model has hundreds of billions of parameters. It requires months of training time. And to keep such big amount of data to train the model and also model itself, we need large scale storage, petabytes of storage. So what's the option for infrastructure for enterprise companies that want to use AI? One is in-house, build your own. Other one is go to public cloud like AWS, Microsoft Azure, Google Cloud. And the third option is AI data center. So the most known now is Stargate project in Texas that cost like $500 billion. And from the cost consideration, the most expensive option is go to the cloud. The least expensive option is to go to specialized facilities like AI data centers. But what is AI supply chain? So it starts from training process. So they need to have data sets, images, videos, text, PDF files. And the common approach is to start with pre-trained model. For example, foundation models that can do image recognition. And after that, they can do fine-tuning. For example, to fine-tune it, to teach it, to do anomaly detection in X-rays. And this is iterative process. So it's multiple subsequent versions. They do evaluation, they do testing, and they deploy it to the model hub. So after that, when the model is ready, they need to deploy it in production. For example, can be web application that can do home price prediction. And what is model? Model is binary file. It's very large binary file, maybe large. And it's a black box. From the security perspective, it's not easy to inspectable it. So you can go, I mean, attacker can go and change ways of the model, can even do it surgically, override parameters, but the damage impact is unpredictable. So it usually will cause performance degradation, but there is no precise control. So it's not like normal hacking of the program. Normally, hackers do reverse engineering, and after that, they change the code. They can build application and replace it. With model, it's much harder to do. So you don't know how model works. It's still even data scientists that work in companies like OpenAI or Claude, Anthropic, they don't know how the model exactly works. So the only way to make damage is just go and just change something. So what's a typical AI supply chain attacks? First of all, you can go and change and modify the data. If attacker modifies the data, the training will create the poisoned model. Another option is data set or model replacement. So like two things. One is poisoning, another one is replacement. And it can happen on each stage of this supply chain pipeline. Yeah, I want to provide some examples of data poisoning. So first of all, Google report says that attackers only need to control 0.01% of the data set to completely poison the model. Don't need to change the entire training data. It's enough to change a small amount. So small data corruption will cause large consequences. And here, let's see some attack types and examples. First of all is corrupted image attack. The scenario is this stop sign is mixed with speed limit sign, and that causes confusion. So think about a self-driving car AI that was trained on this type of data. So the impact will be life-threatening because in the reality, it can interpret the science wrong. Another thing is backdoor poisoning. So in this picture, is it Bob or Alice? The trigger is small yellow square in the corner that I exaggerated it, but in reality, it will be invisible for human eye, but it will be visible for training process. And it will cause to misclassification. So everything works normally until trigger is activated. Based on these triggers, that will do the wrong classification. The third one is feature collision. So the technique is subtle noise injection. For example, this is number 3 plus noise and can be interpreted as number 8. So the impact will be data recognition errors. Here is another type of attack, which is model replacement. And this is particular use case. It happened for Hugging Face, and Israeli company Wiz done the ethical hacking together with Hugging Face. So Hugging Face is a centralized platform that to host, share, and use AI models. It's trusted by developers community, and it's foundation for many AI projects. So let's figure out this ethical hack step by step. Number 1 is initial infiltration. So they upload malicious model. It was based on GPT-2. And after that, they start doing prompt injection. So they send prompts with executable commands, and the target is model process prompt as instructions to operating systems. The result backdoor will be activated, and the model gains administrative control over the operating system. So the step 3 is model replacement. Now they take the legit models uploaded by other project, and they bring them to attacker's site and start fine-tuning it. So they will replace legit models with malicious versions. And remember, model is a black box. Scanning doesn't help. So the payload that they added to this model is to generate malicious SQL program code. And after that, step 4 will be infection of supply chain. So the vector is legit developers download compromised models. And as a result, this compromised model will generate code, generate SQL used in their projects. And as a result, it will be widespread malicious code deployment across the world. So, Carol Clemens, who is CTO of JetBlue, said data will not leave our organization perimeter. So she afraid that when she upload data to AI data center, to the other companies that can do collaborative AI, that can be misused. So the question is how to use the AI data center, how to collaborate with partners. To support AI, companies have to refit infrastructure. Other requirements for new infrastructure is supporting various silos and data platforms, because now data is usually, it's not within the same data storage. It's a lot of collaboration, a lot of partners want to collaborate together on AI research. Another thing, security should not kill performance and should not have any business impact. So it should support data analysis in real time. And security is very important. Data privacy, which is normal security, and data integrity, which is maybe the most, it's an addition for AI, because we need to protect that data is not modified. And also compliance. So US has NIST, AI RMF, and European Union has AI Act. So we already have compliances, and we need to adhere to these compliances. So what's a typical approach to securing data? So first of all, it's encryption. The benefits, it's protect confidentiality and integrity, but there is a drawback. There is a performance impact because the encryption degrades the speed. You need to decrypt data first. And another thing, data platforms like OpenShift, like Databricks, they don't support working with encrypted data. So need some support for platforms. Another thing is access control. Access control, it's a typical approach for data privacy. And the benefit, it limits attack scope and impact, but there is a risk, insider threat from sysadmin. So sysadmin has a full control. Another option is scanning and audit logging. So company can track data access, data modification, and after that to process it and to trying to figure out some malicious activities. But it's actually hard to distinguish among real versus fake alerts. It will be a lot of false positive, false negatives. And the fourth one is verification. The benefits, it ensures data integrity, and limitation is it's no data confidentiality protection, and it's not integrated with existing tools and platforms similar to encryption. So I'm going to talk more about encryption because our company solution. And to explain what encryption is, let's compare it with tokenization. So tokenization is typical approach for data privacy. So if they see some sensitive areas like Tom, like this phone number, they identify it and they replace it by tokens. And after that, in production, they need to replace it back. So encryption just takes the entire file and converts it to encrypted. Using key and algorithm, it converts it to encrypted file. So it's much easier to use. There is no need to identify sensitive areas, no risk of missing sensitive areas. It can support easily some unstructured data like videos, PDFs, images, omics data. And the maybe most important, it protects against data poisoning. Because if you tokenize the data, you still have not tokenized parts. So for example, sysadmin can go and change the other areas. Now, what is AltaStata? So AltaStata provides what's called zero trust. Zero trust meaning that even system administrator of the company is not trustful person. So he can change some data, and zero trust solution will prevent it. So it will be full access control of the users on their data and no insider threats. But so why AltaStata, while not other encryption solutions? AltaStata solves the two pushbacks. One is integrating with data platforms. Another one, it enables real-time performance on encrypted data. So let's see how it works. So in the computer of data scientist, for example, using AltaStata, he can encrypt each file and put it to the storage, to the cloud storage, for example. Now, AI application has access to the entire storage, but AI application, to access particular files, AI application also should have the access to decryption keys. And data scientists can share only part of decryption keys with AI application. So it may be million files here. But if data scientists shared only 100 files, AI application will have the access only to the 100 files. Besides of encryption, we'll also do verification and compression on each file. That solves other problem. So as a result, the model, AI model will be protected in training and in use. So our product is AltaStata Fortified Data Lake. It works with any file format or stream. It can be established in any cloud or private storage. We provide user-friendly application. We provide seamless integration with data platform. Red Hat OpenShift, Databricks, NVIDIA CUDA, PyTorch, TensorFlow, all these platforms are standards. Google has also custom, I think, custom data set. We still didn't create plugin for it, but it should be pretty simple, actually. So as a result, AltaStata provides invisible security, so data scientists can focus on their core tasks, and AltaStata handles security transparently in the background. I want to show some example, and this example is called data clean room use case. So the business challenge is Nike wants to use Walmart's data for targeting their customers with advertisement. But Walmart doesn't want to share all the receipts with Nike. Their data is gold. And Nike also doesn't want to share other retailers' data. So they need to do joint data analysis in the data clean room. Data clean room means that they can do collaborative research, but nobody sees data of each other. So for that, they come to some AI data center, and this AI data center established AltaStata Fortified Data Lake that now provides protection. So for each participants, it creates secure box. And the data will be shared with application only, not with humans. So each data partner has remote access without, each administrator now can upload the data into the secure box. Nike's administrator and also Walmart administrator. And now they provide references to particular files to AI training application. They also can work with data partner. So data partner can use its own cloud, establish AltaStata data lake in their cloud, and provide access to synthetic data to AI training application. So now they can work together within the clean room, create the model, and this model will be uploaded into production application. And now admins can share particular blue files with production application that runs AI model. And in real time, it can process the data and share advertisement to Facebook. So real time here is critical feature because when you go to your page on Facebook, it should provide the image of Nike if you're buyer of Nike, potential buyer. So the key benefits of this architecture, it will be zero trust. So application access data without human exposure. Besides of encryption, we also do data compression, which has two benefits. One is speed enhancement. So there is a 3 times faster downloads of encrypted data using AltaStata than unencrypted using Cloud SDK due to compression. And another thing due to compression is cost saving. It's for some types of data like large text files, it will be up to 63% reduction in cloud storage costs. So to recap, why AltaStata? So how the modern organization works. They have multiple silos, multiple data sources. They work with external partners. They need to process data and do the transformation. They need to do AI training. They need to perform inference in production. And they also do collaboration, secure sharing the data with their partners. So current industry challenge is AI training data integrity, external sources trust issues, no fine-grained access control, and security blocks efficient use and productivity for AI. So AltaStata can help. AltaStata provides invisible data privacy and security, enables secure collaboration and sharing, fine-grained access control, and still ensure real-time performance, easy to use, and cost saving. So with that, happy to hear your questions.
So if a company wants to adopt this, I mean, I like your model of, Walmart and Nike wanting to share resources but don't want to give away any secrets. So how does all that work under the covers?
You mean
His patent?
Well, what I mean is, so if Walmart, what's Walmart sharing with Nike,
yeah,
and
so
how is Nike using that information?
for example, Nike shares some documentation related to the products
Hmm.
and actually how they work with different retailers. And Walmart shares receipts where Nike was purchased.
Hmm.
So they can go together to training application, and training application will do collaborative research. So it will just take.
Right. So you're saying that the collaboration allows Walmart to use their data and Nike's data without being exposed to Nike's data.
Correct.
That's extraordinary, isn't it?
Yeah,
I mean,
for
it really gives them a lot, the solution provides a lot of leverage, right? Now, how many companies, so you said two companies, but how many companies could be involved in the same model?
it may be more because Nike works not only with Walmart but with other retailers, so they can use other retailers' data.
And so what's in it? Why would one company go, you know what, we should have this?
Why Nike? Nike's needed to send advertisement to particular users, so they don't want to send massive campaigns to nowhere. So if you bought Nike at Walmart, you're a targeted customer. So when you go to Facebook, they can send on your page advertisement of Nike.
Hmm. Just so you know, that's why I don't use Facebook, but okay.
Data
Anyway,
cross-pollination, data overlap, something like specific segments without giving the
that's
personal data of the customer.
That's a huge market, actually. Facebook lives from this, Amazon lives from this, Google lives from this. In particular, Google now goes to, I think, estimation is that YouTube will be a major advertisement platform in 10 years because people are going to watch video. And yeah, but it's not only for this. It can be, think about medical research. For example, some hospital has MRI scans, and some research institution has genomic data. And some partners may have some synthetic data related to previous researchers. They also can collaborate this.
So where the
Yeah.
patent works, at what moment,
Uh,
at what level?
Yeah, the patent is about how the key management, because it's automatical key management. So it's, let me show you. Uh, yeah, let me show how it works.
This is really interesting.
There is specific service very much needed.
That's actually what, let's go to Google Cloud for this. So we support all the Amazon, Azure, Google, but let's go to Google Cloud. So instead of working with Google Cloud Console, you can just use AltaStata, and you can just go and take some, let's put my picture. Let's put some other picture. Yeah, and what happens that what I did now, I just uploaded these files to Google Cloud in encrypted format. Now I can do preview. I can do, I don't know, some PDFs. And what I can, okay, where is the pattern? So what I can do now is I can just go and share with another user, Alice. And key management system works automatically. It's easy to use. So Alice now can go, Google RSA Alice. So Alice now received notification that Bob shared data with you. So now Alice can go and see same files. But if you see here, the Bob is owner, but there are two readers, Alice and Bob. So it enables very easy collaboration across data. Now think that Bob is Walmart and Alice is Nike, so they can collaborate on data. But okay, you can collaborate on data using just Google.
Google Drive.
Google, yeah.
Right.
So
And Walmart's not sending over its spreadsheets. Here's all our information.
the difference here is that Google Docs is great to collaborate across humans, but that enables to collaborate not only across humans, but also across humans and applications. So Alice can be not human, It can be some application that use Alice's credentials, and the data structured this way that it enables to process it in real time, process encrypted data in real time. So if we go, let me show something different. I want to show I have some prepared PyTorch test. I don't know. Are you familiar with PyTorch? Is Python package that does machine learning. And I put some data, CSV files, some images, circles, rectangles. And this is data that now I want to train the model. So if I go here, this is actually Red Hat OpenShift. So what I want to do, I have, this is parameters for user Bob. And what I want to do is to, first of all, to train the model. And after that, to run the model. So the important thing that this data now is encrypted on AWS cloud. So what I want to do is I have Python application that uses PyTorch that actually train the model. So this is training process is running. And here's how it uses this encrypted data. So normally it will be just data set. So this is standard PyTorch data set approach, how to read from local file system. This was with AltaStata. So totally same, just 2 lines of code change. And now what I did, I trained the model. So what I want, and if we go here, we see now model. It's, and we also see the provenance text. This provenance explains to user what data we use to train this model, just in case they want to have lineage of the sources for this model. Now what I want to do is just to run this model for image recognition. So yeah, so it recognized circle, it recognized rectangle. So what we have now, we have a totally standard PyTorch pipeline, but both training data and model stored in encrypted format. So it's immutable, nobody can change it. It's protected against sysadmin. It protects it against malicious user, against errors. Pretty easy to use.
It's very cool.
Thank you, Serge. Anyone has more questions about it? I will quickly ask about how to be accepted at the Google Startup program and what does it mean?
Actually, they found us, so we didn't find, but we participated in it must challenge our accelerator, which is in Boston here, and they found us through mass challenge. So Google now looking for first approaches for their AI platform, and they provide credits. So they look such startups in the accelerator graduates, and AltaStata, so they found us.
So they're giving you server space and all the resources you need.
They gave us like $25,000 credit, so we can use their cloud, yeah, for AI.
That's pretty great. Now, just so I know, have a sense of scale, how much can $25,000 buy using your model?
I still don't know. So I think for us it's too much because we are data.
We won't tell Google.
We are data security. We are not we're not.
Right, right. You're not generating much
We're
except
not generating much data, yeah, but
yeah.
we will think how to use it. Yeah, that's.
Good
If you
idea,
have
right?
any idea, come us.
Partners,
This is we're
partners.
Yulia, we're back to the beginning when we're talking about Craig and his server, right?
Yeah, partners. This is a good marketing tool, actually. If you would be attracting your partners to try your product and giving them some cloud credit.
Actually, yes. Yeah, I think that's maybe the good idea, Yulia. Yeah, so maybe we can suggest to some partners they will use AltaStata and they will have some Google credits for free.
At least to try. As
Yeah,
lure
you're a
them,
genius.
tease them, bait, using the cloud
Uh,
credit as a bait, right?
It's a good model. It's a good model to get
That's really
customers.
nice idea. I didn't think about it.
So, Serge, you have a client list now. I mean, there's people that are really using this in production.
We work with Massachusetts Open Cloud. It's an organization that combines Harvard, BU, and they protect data for Boston hospitals. So we are now still, they don't pay yet, but we are now on integration stage and they're really excited about it.
Is
Great.
it
That money
Lucas?
will be coming soon.
Is it
We'll,
Lucas?
uh, no, it's not focus. No, it's different.
Okay.
No, I don't. Lucas does
I did introduce
genomics.
to Lucas. So I'm wondering what
Yeah, I
was.
spoke with Lucas. Lucas said that he might be needed by the end of the year.
Okay. So for himself.
So for everybody else, Lucas is an AI developer in Boston. He's been working with a big genomics company,
And he
and
is
he's also a
actually
GDG
GDG.
organizer
Yes.
and a GDE. Yeah, so he's a Google developer expert. What's his
So
expertise? Do you know, Julia?
cloud,
What's he an expert
cloud.
in?
First of all,
Is it
cloud.
cloud? It is
Yes, it's
cloud, yes.
healthcare.
And
It's
he's brilliant.
healthcare genomics. Yes, and he's really into academia, so he's just playing with the models.
And he's a fun guy. He's really fun to be with. Great to talk to.
Yeah, GDG Dev Fest is coming. So I just hope from the meeting with other GDG organizers. So Dev Fest in Boston is just under the planning phase right now. We did schedule ours, so I hope you will attend. And we really want to see
Our
exciting
Dev Fest
projects.
is Our Dev Fest is October 30th, excuse me, October 31st, November 1st in Troy, New York at RPI. And we'd love all of you to come. Serge, we'd love you to come and speak as well.
Happy to do it. And if you, John, if you or anybody else, so if you have some idea who might want to try it, to use it, we are now on this stage. Yeah.
Yeah, that's great.
We also work cooperating with Red Hat pretty actively. Like we have weekly meetings with their CTO group.
Oh, excellent.
And yeah, so we hope that it will have some outcomes. Actually, they found this Massachusetts Open Cloud.
I never heard about
that was
this
a
actually.
pretty good piece to add.
Massachusetts Open Cloud, yeah,
Tell us more about
because
Massachusetts
they
Open
don't
Cloud.
know how to do marketing, Julia. They don't have you. Yeah,
Okay.
you don't have somebody with such ideas like you
Thank you, thank you,
propose
thank you.
now.
Okay, thank you very much. Just to switch gears, I think we need just to do something else today. At least I have some plan to do today, but feel free to reach out to Serge. So I do encourage everyone to put their LinkedIn profiles into the chat. This way you kind of make a connections. You will, who knows, right? When and what is needed. I would probably speak on behalf of Venkartat Harmateja, if I'm saying your name right.
Yeah, you're speaking right.
So he's looking for the job and he's a brilliant guy. So if you are interested to give him some projects to try to do something and just to partner up, maybe this is a good opportunity because he's into AI after Marist University. Do you want to tell a little
Yeah,
bit
yeah.
more about your previous experience with India and what's the difference between India education versus Marist education?
Okay. Yeah, sure. So, I worked as a data analyst for most of my time. Um, and compared to and the education system you're talking about, I mean, I felt more practical here. and it was more theoretical back there. So we used to have a very less hands-on experience. I mean, I don't know right now how the culture is, but because I have completed my graduate undergraduation like 5 years back. So the education system here is very practical. So I got a lot of experience by doing hands-on projects. I have done so many simulations, and I've done uh, I've been constructing some AI workflows in NA10. I just started a workflow today, working on it. It hasn't completed. I thought to complete it by 5 o'clock today so that I can present to you guys, but I couldn't make it. Uh, so yeah, I would love to have a project to work on. I'll try my best to complete it. So yeah,
Okay.
thank you.
Okay, next I will share my screen and just show the document which was mentioned, if you don't mind. So it was actually good to meet in person the other week. So Charlie and Hartford Harma Teja did attend in person, and we were thinking like how we can share our documents and what do we do about this. So we started with this document. This is the um, short link if you want to take a look. I don't know if you see well. Shall I make it bigger or what? So basically, the first tab here is how to join our community. Here is the GDG Hudson Valley, HVTech Slack, Open Hub Slack. This is our call for speakers. Please, please, please submit your application. Even Lightning Talk, just come, register, and attend. We do believe it's really cool event with like 400 people at least attending at RPI this fall. Next meeting, virtual meeting, is August 21st. We will have the in-person meeting in between now and there, but we need to find the space to and just location where we're meeting in person, and it's totally different energy when you meet in person. So this is our today's event. This is mine.
This, just so you know, sorry to interrupt, Yulia, but this
Yep,
document is the link that I put in. It says also look at our shared doc. That's what Yulia is
exactly.
pointing at. And it's an open doc, so put in your information in here, and we'll use this as a notes, etc., moving forward.
So just mention that we did meet and discuss something at July 8th meeting. So we did talk about this cool image. We did mention those resources, and that's the image which I did share. So it's really good for at least for vibe coding, but turned out not only. And the last tab I want to mention is the video tutorials, which we actually collected throughout all our DevFests. I promised to talk about labs. So if you want to do any labs, so that's a first thing to watch. And workshop materials and codes for building her lab specifically is here. So just saying it out loud. Anything else is just to add and play. If you want to share, take your time and do something right now. Just it's your time to do the lightning talk, to ask, to say. And if you want to switch to labs after this, we can do that. I did email to everyone on Meetup because I wanted to say that Google is giving us a good cloud credits as well. So it's kind of season of giving, giving
Season of
generous,
giving.
yes, generous cloud credits.
Great.
Questions, suggestions? Maybe Frankis want to say something. How was it for you? Was it useful? What do you want to do next?
No, this was very useful. I'm not sure where to go next. That's the problem.
Okay.
Oh yeah. Okay. Oh yes. Yulia, what did you want? You wanted to talk about the labs, yeah?
Yes, I did. I don't know if we're ready. Do you want to talk about labs now?
What else were we going to talk about?
Whatever you want.
Lucky me.
First thing I will do is probably I will stop the recording. Yes, no, I don't know.
Yeah, yeah, you can stop the
Where,
recording.
where I am recording? Yes, here. Okay.